Question 12 from section 5.5, I think. Yeah, section 5.5 something. A lot of stuff going on here in regards to being able to address the law of sines. When it says the angle of inclination, what that means, angle of inclination is essentially when your line of sight follows a predefined object as a hillside or something similar. So what they're saying here is if I'm dealing with my angle of inclination, which is the hillside, to get to the tree. So let's say that the tree is right here. There's my tree. The angle of inclination, which is, they're saying that lowercase b, is 21 degrees. Okay, 21 degrees. They then say that the angle of elevation to the sun, so angle of elevation is, remember, the line of sight to the object that you're viewing. So the sun is what we're viewing. It's a terrible sun. That angle is right there, and we're saying that that is 51 degrees. Okay, 51 degrees. And they're essentially then asking, can you find the height of the tree? Can you find that distance right there, which is h? So what I'm hoping you guys see here is that we're being asked to kind of deal with the law of sines inside that triangle. Now, it's a little bit more difficult to use the law of sines. It's not as easy as just maybe some of the other questions where everything is just presented initially for you, because we don't have very much information about that triangle. We essentially have the ability, and it's not explicit, it's kind of implied what that angle right there is. Okay, that angle is going to be 30 degrees because we know that this angle of elevation, which is this angle over here, they're talking about A, was 51 and B was 21. So that means this angle here between the hillside and this yellow line of sight, that is 30. All right, I just wanted to put a little bit of a better looking picture together for you. So 21 degrees here, 51 degrees there. So that makes this angle right here 30 degrees. So it's going to be important. That's 30 degrees. Throughout the question, it says the shadow that's casted by this tree comes all the way down that hillside. And that shadow is 245 feet long. Looking then at the triangle that we want to find, it's a non-right triangle, obviously. It's this triangle here that we're trying to find the height of the tree with. Okay, and you've got some maybe other, just kind of going off of maybe using SOHCAHTOA might be an approach here. I was trying to think. It might not be too bad to use SOHCAHTOA with the entire right triangle here. But I'm going to do a little bit of work that allows us to directly use the law of sines. To use the law of sines, obviously if I call this yellow angle down here A, call this one up here B, and call that one there C, I would want to say that the sine of A over sine of A being that angle right there, should be related to that distance right there. I'm going to call it H. That's the height of the tree. That's what we're looking for. That should then be equal to the sine of B over 245, because 245 is the side opposite B, so 245, which is equal then to the sine of C, which is then divided by this distance AB. I'll just call that lowercase c. If I start looking at that stuff, I can't choose any of those two ratios, because any two that I choose, I'm going to have more than one unknown. Okay, so the idea is, can I look at this picture? Can I start to walk through this picture to find some other angle measurements? And here's the idea: is that we understand that this tree here, we're gonna assume that it's growing perpendicular to the horizon. Okay, now I know we got this angle, this hillside here, but there's a horizon you can kind of implant in there, and that tree is going to be perpendicular, so there's going to be a right angle there. And that right angle might be something that you can kind of negotiate through this using law of sines, law of cosines, maybe. I don't know. I know you can at least find this distance here using SOHCAHTOA if you needed it. But using law of sines, now I know that's 90 degrees. I knew that this was 21 degrees. Okay, that's 21. This is 90. Okay, so if that's the case, then this angle here has to be 69. Okay, because I'm looking at that kind of clear triangle there, and they gotta add up to 180. That being said, then I know that this here is 111 because it's got to be supplementary with the 69, making this angle up here then 39. And there's other ways we could do that. We could look at the fact that, looking at the right angle. And that right angle is 51. This one's 90. And then that one has to be 39 if we're looking at the entire red triangle adding up to 180. So there's different approaches that you could use to find those missing angles. But now that I've done that, what's really nice is angle C, that's going to be 111. Okay. Angle B is going to be 39. And now, by plugging that stuff in, I see, angle A is also, angle A we said was 30. Okay, by plugging that stuff in, I can now grab those two ratios and work through and figure out what H has to be. I can go H sine of 39 is equal to 245 sine of 30. This will give me H is equal to 245 sine of 30, and then divide that by sine of 39. And that will end up giving me my H value, which when we calculate that, I think I've already, nope, I haven't done it yet. 245 sine of 30 divided by sine of 39. There's our 194.6. It says round in the nearest foot, so that's why we're getting that 195 there.